Namaste dosto. Have you noticed how certain angles keep popping up again and again in geometry problems? That's because trigonometric ratios at special angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees are super useful. These angles aren't just random. They show up so often that knowing their exact sine, cosine, and tangent values can save you loads of time during exams and homework. Imagine trying to calculate sine or cosine for some random angle without a calculator. It can be tricky. But these special angles, you can plug them right in and get exact answers. No calculator needed. That's why it's a great idea to memorize these values. These exact numbers come from neat shapes like special triangles and the unit circle, which help us understand sine and cosine as coordinates on a circle. Picture the unit circle, with the x-axis and y-axis intersecting at the center. Each of these key angles corresponds to a point on the circle, where the coordinates tell us the cosine and sine values. So, mastering these special angles is your golden ticket to solving many trigonometric puzzles faster. Ready to explore how we find these values? Let's move on. Great! Now, let's dive deeper into those magic angles, 30 degrees and 60 degrees, using a simple yet elegant shape, the equilateral triangle. Picture an equilateral triangle with all sides equal to 2 units. If we draw a line straight down from one vertex to the opposite side, called the altitude, it splits the triangle into 2 right-angled triangles. Each of these right triangles has angles of 30, 60, and 90 degrees. The longest side, the hypotenuse, is 2 units. Because the altitude cuts the base into 2 equal parts. The base of this right triangle is 1 unit, and the altitude, let's call it h, is that unknown height. To find h, we use the Pythagorean theorem. The square of the hypotenuse equals the sum of the squares of the legs. So, h equals the square root of 2 squared minus 1 squared. That's square root of 4 minus 1, which simplifies to square root of 3. From here, the sine of 30 degrees equals the length opposite the angle over the hypotenuse, so sine 30 degrees is 1 divided by 2. Similarly, cosine 60 degrees, which is the length adjacent over hypotenuse, is also 1 divided by 2. For the other angle, 60 degrees, sine 60 degrees is the height h over hypotenuse, which is square root of 3 divided by 2. Cosine 30 degrees is the same value. Isn't that neat? Using these side lengths, we can also find tangent, cotangent, secant, and cosecant values for both angles. And all of this comes straight from a simple equilateral triangle. Shabash for following along. Moving on, let's now focus on 45 degrees, another very important angle. To see where its values come from, imagine an isosceles right triangle, where the 2 legs are equal in length, say 1 unit each. Since the legs are equal, the 2 angles opposite those legs are both 45 degrees. Now, what about the hypotenuse? Using the Pythagorean theorem again, the hypotenuse squared equals 1 squared plus 1 squared, which is 2. So, the hypotenuse is the square root of 2. Time to find the trigonometric ratios. The sine of 45 degrees is the length opposite over hypotenuse, so 1 divided by square root of 2. Cosine 45 degrees is exactly the same, also 1 over square root of 2. To make it look cleaner and easier to work with, we rationalize this value. Multiply numerator and denominator by square root of 2. This gives us sine 45 degrees and cosine 45 degrees equal to square root of 2 divided by 2. And what about tangent of 45 degrees? That's sine 45 degrees divided by cosine 45 degrees, which equals 1. This means tangent 45 degrees is 1. Other ratios, like cosecant and secant, can be found too. Cosecant 45 degrees is just the reciprocal of sine, which is square root of 2. A simple triangle with legs 1, 1, and hypotenuse square root of 2 explains this beautifully. Excellent. Now, let's bring all these values together into a handy table that you can use anytime. It lists the 6 main trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. evaluated at the angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. For example, sine of 0 degrees is 0, because at 0 degrees, there is no vertical height on the unit circle. Cosine 0 degrees is 1, as the point lies entirely on the x-axis. Similarly, tangent 90 degrees is not defined. Why? Because tangent is sine divided by cosine, and cosine 90 degrees is 0. So division by 0 is impossible. Let's put our knowledge into action with a quick example. Suppose you need to calculate tangent 30 degrees plus cotangent 60 degrees. First, recall from our special angles that tangent 30 degrees is 1 divided by square root of 3. Now, cotangent 60 degrees is the reciprocal of tangent 60 degrees, so it's 1 over tangent 60 degrees. Since tangent 60 degrees is square root of 3, cotangent 60 degrees is 1 divided by square root of 3. Adding them together, we get 1 over square root of 3 plus 1 over square root of 3, which equals 2 over square root of 3. To write this in a simpler form, let's rationalize the denominator by multiplying numerator and denominator by square root of 3. This gives 2 times square root of 3 divided by 3. So, the final answer is 2 times square root of 3 over 3. You can verify this matches values in our standard trigonometric table. Excellent job! This example shows how knowing exact values of these key angles makes calculations quick and accurate. Before we wrap up, let's quickly summarize the key takeaways. First, sine 30 degrees equals 1 half. Similarly, cosine 60 degrees equals 1 half. These come directly from the equilateral triangle construction. Second, sine 45 degrees and cosine 45 degrees both equal square root of 2 divided by 2, which we found using the isosceles right triangle. Third, tangent 0 degrees is 0, while tangent 90 degrees is not defined because of division by 0. Remember, these special angles give exact trigonometric values thanks to well-known geometric shapes. Also, sometimes we rationalize expressions to get standard forms, like turning 1 divided by square root of 2 into square root of 2 over 2. Don't forget, undefined values usually happen because dividing by 0 is impossible. Finally, having these values memorized or in a table saves valuable exam time by reducing calculation effort. So, practice these well. It will pay off in your tests and help you understand trigonometry on a deeper level. Arey vah! You've done a fantastic job exploring trigonometric ratios for specific angles. Keep practicing, and these will become second nature. Until next time, keep enjoying the beauty of maths.